Hello everyone, welcome to my channel Mathenthusiasm. This video is day 8 of the 30-day challenge. It is all about integration by parts. In this video, we shall use this integral to answer the following questions. How many times of integration by parts do we need? Do we know it before we really do the integration? Let's check it out. Integrate x cosine square x dx. First of all, we have to decide which term to be absorbed into the differential. Because x is algebraic function a, cosine square x is trigonometric function t, by the last rule, a is in front of t. So a is u and t is dv. In other words, we have to absorb cosine square x, that is to integrate it. However, there's no simple formula to integrate cosine square x. What should we do? Let's recall the double angle formula. Cosine 2x is equal to 2 cosine square x minus 1. Rearrange the terms, we have cosine square x is equal to 1 over 2 times bracket 1 plus cosine 2x. We put this inside the integral. Then we can reduce the index from 2 to 1. Next, we are going to separate the integral into two parts like this. For the first one, integrate x dx. It is easy to evaluate. The result is x squared over 2. Now, we focus on the second integral. It is still a product of a and t. Therefore, by last rule, we can integrate cosine 2x into the differential. So the integral becomes 1 over 2 times integrate x d bracket sine 2x. Let's take out the common factor 1 over 2. Therefore, it is equal to 1 over 4 times bracket x squared plus integrate x d bracket sine 2x. Now, we can compare it with the formula of integration by parts. U is equal to x and v is equal to sine 2x. Then the first term is the product x times sine 2x. The second term is the integral by swapping u and v, which is integrate sine 2x dx. It can be evaluated easily. It is negative 1 over 2 cosine 2x. Therefore, the answer is 1 over 4 times bracket x squared plus x sine 2x plus 1 over 2 cosine 2x plus c. Let's go back to the question at the beginning of the video. How many times of integration by parts? On the previous 3 days, the integrands have square terms, and we have to apply integration by parts twice. But for this integral, even though there's a square term, we only apply it once. In fact, it depends on whether the square term is u or v. For these three integrals, the square is at u, while for this integral, the square is at v, and the index of u is still 1. Therefore, we get an important result from last rule. Apart from determining which function to absorb, we can predict the number of times of integration by parts before we really performed it. Here is the thing. In last rule, the function on the left is u, and the index of u is equal to the number of times to apply integration by parts. This is such an important result. Let's see how to use this in the next video on day 9.